31, next permutation. So we need to implement next permutation, which rearrange numbers into the lexicographically next greater permutation of numbers. If it's not possible, we must rearrange as the lowest possible order. The replacements must be in place and use only constant extra memory. So, for example, 1, 2, 3. Next one is should be 1, 3, 2. Yeah, because 3 is the last one, biggest one. We can change. We can only change the next digit, which is 2. Yeah, 3, 2, 1. This is already arranged in the descending order, so it's not possible. We need to return in ascending order. 1, 1, 5. It's like 1, 2, 3. We change 1 to 5. So we need to define what the next permutation is, right? The lexicographically next greater number. It's like if we have every lexical. Wait a minute. So 1, 2, 3. There, we should increment the last digit, but 3 is the largest one, so we can only change the next digit. This 2 versus 3. Yeah. So there's a possibility of 3 here. So we need to switch it. Like if there are like 1, 2, 2, 3, 1, 2, 5, 4, 1, something like this. What should it be? So 5 is the largest one, right? Look, like there is one. If there are same numbers, yeah, it doesn't matter. So if it's like this, the next one should be 1, 2, 5, 4, 1. So if it's 1, 2, 5, 4, 1, or 5, 4, 1, you see that the 5, 4, 1 we cannot change anymore. They're already in the descending order. So we need to change the next one, which is 2, which is changes to the one bigger than 2, which is 1, 2, 1, 4. Okay, and then we should make it the 2, 4, 1 the smallest. So it should be 1, 1, 2, 5. So what we can get is that the order is like actually for like one like this case 4, they are numbers like 1, 1, 2, 4, 5. This is ascending. Make it ascend. We need to switch it to 5, 4, 2, 1, 1. Make it descending. And we need to do it in a, from the right to left. That reminds me that we actually could start scanning the number array from the right to left direction, and we find the ascending slope, which is from our perspective, like 4, 5. This first ascending slope. Actually, we should move the target there, right? Because we are transforming these ascending order to the descending order from left to right, from right to left. So what we do is to find the first ascending slope, and the first element we found that becomes the from okay, the order is from right to left. Okay, let's make it this to this. Like we have 1, 2, 5 for 1. If we put it in a more graphical way, it should be 1, okay, 2, 5, 4, 1, right? So we scan the numbers from right, and this is the first slope we met. This is the peak, first peak, and the next number, we should increment this number. So what it should be? It should be 4. So the 4, we should need to scan it again from right to the first peak and find the first number, which is 4, and switch it, right? If that's true, we switch it to number 5 and 2. The order here is still ascending. It doesn't change because we are finding the number which is bigger than 2. Or, that's bigger than 2. Yeah, it doesn't change. So 1, 4, and now we need to, this is not right. We need to change it to, in a descending order from right? So yeah, this is next number. Wow, cool. We find the solution. And how we can do it? It's if I say the first one, 1, 2, 3, 4, 1, 2, 5, 1, 4, it's like this, right? Yeah, so again, we find the first slope is 4, 1, and okay, and we need to find the first number which is bigger than 4 here, and switch it. And there's only one 4 here, so we do the switching. And we got it. Cool. And what if you find the already descending order, like 5, 4, 2, 1, 1? Yeah, for this case, we cannot find any ascending slope, so we failed, right? We finally find the impossible permutation, so we just reverse them. And we are asked to use only constant extra memory. Actually, we only need one constant extra number to swap the two numbers, but we needed to reverse this array. How can we accomplish that? If we have one extra array to reverse 4, 5, 2, 1, 1. First we sort. How can we do that? Yeah, we can first sort 4, 5. Just as we did last time about reverse nodes in a linked list, we use an extra number to reverse 4, 5, and then reverse 4, 2. No, not 4, 5. How can we do this? I know that in JavaScript. God. For the simple solution, we can just put these numbers in an array and just reverse it. But in that case, we need an ON extra constant extra memory, so that's not possible. The problem becomes how we can reverse the linked list with an array with constant memory. Five, 4, 2, 1, 1 with extra memory. We can just swap with two cursor, with left right cursor. We switch this one. This must be the biggest, and this must be the smallest. So 1, 4, 2, 1, 5, and then we swap these two 1, 1, 2, 4, 5, and when they met, we don't need to swap. Okay, problem solved. So our solution, I'll write it down. Write it down. The solution. Solution is find from right to left. Find the first slope. Ascending. Well, if right to left, we should say it's descending. First descending slope. Get the bottom. From right to left. Find the first number bigger than bottom, which is say x. Bigger than x, which is y. Next to peak. Peaks y, okay. Then x, which is z. Swap x, z. Sort numbers from right to y. Yeah, now let's write our solution. Okay, so the first thing is we need to get the index of the peak. Gets the peak. If we get the peak, we know next one is the bottom. And yeah. So for irregular cases, if the nums are nums is for irregular cases from like this, we just return nums. Oh, now let's start. Let I. We need to find the peak, so let peak. Rightmost peak. For I equals nums length. If nums I minus 1, but find the peak, it should not be 0. If we find if we find that I is 0, we say rightmost peak is 0. Is 0, okay? And break. There's no breaking because it's already 0, so there's no need for a. And if I minus 1 is smaller than, what's the equal case? Like there is it's a double 5. There's nothing bigger than 5, so we need to move to the first one. So so we should need to find absolutely smaller one, nums I. If peak found, if this is this, so right peak is I, and we should break. Okay. Now find the first number right bigger than the bottom one, bottom number. If no bottom, we just skip. Yeah. and switch to the bottom. Swap with bottom number, which means if rightmost is bigger than 0, we switch, right? And we will use for loop again. If nums I is bigger than nums rightmost pick -1, then swap it. So const temp. We can use JavaScript's new syntax. We can just do the swap here, which means like this. This is the right one and the bottom. It should be the bottom. Cool, right? This is really cool. This is constant memory. It's 0001. Okay, we swap it and break. Don't forget to break. And now rest is the odd order. We only need to reverse the order of the numbers to the peak. Cool. So how can we do that? We use to cursor to do inline reversing of the numbers from right to the peak. Let's I equals rightmost peak with j, okay? Let k equals nums length -1, while j is smaller than k. We do this, which is j, k, k, j, and j plus equals 1. I don't like write the abbreviation of +1, like yes +1 or something. The code is really hard to read for me. Okay, so and k -1, and after this done, yeah, everything is done. We return nums. This is, I have to tell you, this is the first time I tried this problem, and I didn't read in any materials. I hope I can make it, and it is marked as medium. Let's run the code. Wow. There's unexpected identifier. Oh, I missed there should be a bracket. And today this is the memorial 5th. It's actually not a wedding anniversary, but which is the proposal anniversary. Oh, it's not proposal anniversary. It's the anniversary of my wife became my girlfriend 5 years ago. So we had a very fantastic lunch, which is actually the dinner is served just right next to our house. It's a Michelin 1-star. It's oh, okay. So it's kind of have a little drink. So I'm a little high now. Okay, accepted. So let's submit. I hope it worked. And wow, yay! It's it works. Cool. So let's analyze the time. Okay. So here, the worst case for this loop is on, and this is also on, and well, this is on too, and so totally time it's on space. Oh, we didn't use any extra space actually, so it's constant. Okay, so cool. Let's submit again to add the comments. Wow, it's faster than 91%. Let's take a look at the solution. I don't know, maybe they're doing me the same. Well, actually, it's this. Maybe they're doing the same. But for brute force, we can find every possible permutation, which is just larger. But this one will be a very naive approach, which since it requires us to find every possible permutation, which this approach is not acceptable right now. As we move on to the concept approach. Oh, I don't need to analyze. Anyway, so that's all for this problem. See you next time. It's kind of like a very cool problem. I think that we need to, like, sometimes we need to draw a graph like this, right, to make it more understandable. And there are little tricks that we can use to do inline modification of array. Yeah, something like this. Okay, see you next time. Bye bye.